So now what we'll do, I'll just, what we'll do is we'll use the image from the first lens as the object for the second. Okay, so here we are, and let me go ahead and draw in so this is where our object is. And what was the height again? The height was 30. That'd be 4, 8, 16, 20, 30 is this much. So there's our image, and it is 36 centimeters to the right of that first lens. So this is, what should we call that? First image. And we're going to use that now as the object for the second lens. So let's see, what should we do first? Why don't we do the ray tracing first, and then we will punch in the numbers and see what we get. So this is, let me go back up to the first drawing. So you can see the red and the green and the blue lines that we chose. Those were conveniently chosen for the first lens because they made it easy for us to draw them. We knew exactly where they went. But for the second lens, those aren't the most convenient. So we're going to choose some different rays, because what's happening is before these rays get to the second, get through the second lens to form this object, the second lens diverts them. So there's actually a second lens here. And these rays are diverted and when we look in, we're actually going to see an image not over here at 36 centimeters from the left lens, but we'll actually see one in here closer somewhere, because these rays get bent and diverted in and form the image in here. So before these rays can form this first image on the right, they change direction and form an image closer in. So let's do the ray tracing first. And this is an F is equal to 6 centimeters. So let me put a couple of dots here. There's going to be a focal point at each of those locations. Okay, so we're going to pick 3 rays to trace. And we're looking at the rays that are coming. We're kind of ignoring this second lens. And the rays are coming towards that first lens, but we want to pick some different ones this time. So the first one I'm going to pick is the one that ends up at the tip of this arrow, or image, but it would have gotten there if the second lens wasn't there by passing through this focal point right here. So I'm going to draw my line like that. So if the second lens wasn't there, the light would have passed through this focal point and ended up at the tip of our first image. But the second lens is there. And so what happens when it hits this lens, it comes out parallel. So the light, instead of going to the tip of the arrow of our first image, it changes direction and comes out parallel to the axis of the lens. The second line I'm going to draw is the one that would, if the second lens wasn't here, would have gone right through that point where the center of the lens is. So the light came in this way, and actually, even with the lens there, it's still going to take that exact same path. It's going to pass right through the center of the lens, so that path is okay. And then the last one I want to look at is this blue line we have up here. The light that was coming in parallel towards the tip of that arrow, but when it hits this lens, it's going to come out towards the focal point. So let's draw that one in down here. I'll use blue again, since I used blue last time for that. So this is coming in parallel. But when it hits the lens here, it comes out through this focal point. How's that? So it comes in this way. It would have gotten to the tip of this arrow if that lens wasn't there, but the lens is there, so it comes out in this direction. And let's see, the red, the green, and the blue, oh, look at that. I've got them all intersecting in a very tight spot there. And so our image is actually right about there, our final image. So let's calculate it to see if that's in the right place. So our final image we have our equation, 1 over our object distance plus 1 over our image distance is 1 over the focal length. The focal length, we're now using the second lens. It's a converging lens, so it's positive, and 6 centimeters was given as the focal length. Our object distance is negative 18 centimeters because our object is 18 centimeters on the right of the lens. So the convention is that we use a negative distance for that because the light, it's not on the same side of the lens that the light's coming from. And we plug those numbers in, and we get our image is a positive 4.5 centimeters. So positive means it's a real image. And it's located 4.5 centimeters on the right side. And let's see, is that 4.5 centimeters? Pretty close. The distance from here to here is, in my drawing, it's pretty close to 4 points. It's a little over 4 centimeters. And let's take a look. We expect it to be the same orientation as our image. Our object points down and our image points down. So we expect our magnification to be positive, and our image is much smaller than our object, so we expect it to be less than 1. Let's see what we get for our magnification. (4.5) over negative 18. The magnification is positive 0.25, 1/4. So let's take a look. Positive means the orientation is the same as the object. So the object was pointing down, the image is pointing down. The object was 30 centimeters tall. So 1/4 of that is 7.5 centimeters. Let's take a look and see what We got almost 8, right? Just looks like a hair less than 8 centimeters. So not bad. The drawing, the ray trace came out pretty close in this case. Better than the first one. So let me just recap. The position, 4.5 centimeters to the right of the second lens. The size, 7.5 centimeters. The orientation is inverted from the original object. Right? Let's go back up to the beginning. Well, it doesn't have to be the beginning. Here we go. The original object is pointing up, and our final image is pointing down. So it's inverted from the original. And it is a real image because the light actually goes through that point and comes from the tip of that arrow. So just to recap, we had light coming from our original object. That light got diverted like that. That light got diverted and was heading toward this point where we're calling our first image. But on its way there, it hit a lens, a second lens. And so as it came in, it got diverted again. And it all ended up forming an image over here, 4.5 centimeters to the right of the second lens.